Hello to Dr. Cheng and my fellow course-mates. We are Group 28 consisting of Brandon, Kerjie, Jingxiang and myself Dylan, here to present about our Smart Class Management System. Starting off with the report. Smart Class Management is defined as a software application centered around automating as well as managing the tracking, administration and reportings of learning events. Basically, it is a collection of other smaller systems with the purpose of, as the name implies, the management of a classroom. Examples of the subsystem are content management system, administration system, as well as attendance system. Since it is considered to be a collection of smaller systems, the strength of the entire system is its portability, as in, the subsystems can be added or removed depending on the user requirement. The focus of our class management system is the attendance system. We provide the smart element by using a facial recognition-based attendance system. The idea of class management dates back to 1950s, where a basic math courseware was created to teach students about math. Later on, between the year of 1960 and 1980, the University of Illinois created Computer Assisted Instruction System (CAI) that provides various class functions such as self-study, self-test, simulation games, and question answering. After the year of 1990, Intel brought forth more development by introducing computers as well as advanced technologies such as cloud computing, AI, and IoT to further improve classroom learning, which is where we still are today. The future for smart class management system is still unexplored. This is because the current applied technologies such as cloud, AI, and IoT still have much room for improvement in terms of efficiency as well as effectiveness. Further tech implementations would include the integration of VR and AR to provide a more visual and immersed learning experience.
Now let's talk about the problem statement. With the development of IT and the informalization of education, the existing class management methods can no longer meet the diverse requirements of teachers and students. During classes, students' attendance is recorded manually, which wastes a lot of time. The way of publishing course information is not convenient and intelligent enough. Using more efficient and reliable technology to manage classes saves teachers and students energy, time, and educational resources. Smart class management system is very efficient to use, but it requires a high cost to develop a mature, safe, and reliable system. The existing smart class management system uses traditional computing model. In addition to significant upfront investment, it has long hardware procurement cycle and involves acquiring, provisioning, and maintaining on-premise infrastructure. The main objective of this project is to propose a solution to reduce the burden of the teachers and students on doing class activities, such as signing attendance, class announcement, and so on. Thus, the objective can be conducted as below. To propose an architecture diagram that uses AWS in order to develop the system quickly and minimize the developing cost. The other is to develop the class management system based on the proposed architecture diagram that can be used in a class or course.
I'm the presenter for this session, Li Jingxiang, and now I'm going to talk about the proposal solutions. At the right hand side is the architecture diagram for these assignments. First, we're going to use a Amazon connector to do the user verification to find out whether this user is a student or a teacher. And then in order to connect the web application, the front-end application with the back-end server, we're going to use Amazon API Gateway to route the request that's sent by the web application and then use Lambda to process the request and then store the data into the DynamoDB. Apart from that, our proposal solution is also having a face sensor to scan the student attendance. First, in order to connect the IoT device, we will use AWS IoT Core to connect the face sensor device with the Lambda. Lambda will be used to process the request from the IoT device. First, we're going to retrieve the stored student image from the Amazon S3 bucket and then use AWS recognition to find out the similarity between these two images. And then if the similarity is high enough, we're going to use Amazon SNS to send the notification to the student to notify that the student attendance is taken. Then that's all for my session.
Good day, sir. My name is Brandon Ling Yong, and I'll be presenting on the comparison of relevant technologies. So there are three cloud system that we are comparing, Microsoft Azure, Google IoT, and AWS. So for each of them have its pros and cons. For Microsoft Azure, it emphasizes on data protection, and it can scale your computer resource up and down with flexible requirements. Its cons is it requires to pay subscription fee, and also it requires management. That means that user data storage or management system will be controlled by Azure itself, and there will be lack of transparency behind. For Google IoT, its pros is that it gives free trials for testing purposes. It provides high quality data analytics and deep learning for IoT projects. Its cons is that it has smaller data center and is less extensive compared to Microsoft Azure and Amazon Web Service. And for Amazon Web Service, its pros is that it provides training and education materials for users to fully utilize the cloud system. This is good for new users who have no cloud system knowledge, and also enables customers to fine tune their computing requirements. Hence, they can use the resource efficiently instead of wasting some of the resources they do not use. And for its cons is that it requires some payment for our storage in S3. So any customers who is buying the storage, we have to pay some price, and it is more focused on IaaS instead of PaaS and SaaS. So for the next slide, I'll be presenting on the implementation.
In this session, I will talk about the API Gateway, Lambda, and also DynamoDB. These three services will be used to build the API server. This server will be used to connect the front application with the database. So the front application will be able to retrieve the data or store the data into the database. For example, in the API Gateway, you can create an API and then do the routing job at here, like student with get method or port methods, and then you can deploy your API and then get a valid link at here. And then in the Lambda, you can build your own logic at here. For example, we have built a very simple user verification logic at here, like do checking the user have a token or not at here. And then we can check the request based on the HTTP method and also the path and retrieve the relevant functions. For example, if you are getting a student data from the student path, it will trigger the get student function. And then you can in this session, I will show the demo. In this session, I will talk about the API Gateway, Lambda, and also DynamoDB that will be used to build the API server. These three services will be in this session, I will talk about the API Gateway, Lambda, and also DynamoDB. These three services will be used to build the API server. This API server will be used to connect the front application with the DynamoDB. This will enable the front application to retrieve the data from the database or store the data into the database. So in the API Gateway, you can create a simple API and create some routing job at here. For example, create a student path with get method and a post method. And then you can deploy the API, then you will get a valid link here. After that, in the Lambda, you can write some logic here. For example, we create a simple user verification job here by checking the header have a authorization token or not, and then trigger the relevant function based on the HTTP method and also the path of the request. So, for example, we can send a get method request to the student path with the student ID and a valid token. Then we will receive the data from the database. Like that, you can receive the ID, name, and the email of the students from the database table here. So that's all from my session. Thank you for listening.
Hi, I'm Dylan, here to explain the implementation of recognition and SNS service. Our facial recognition is done by comparing two images. The source image, which is the student's profile picture, as well as the target image, which is the student's image taken during class. Here, we created an S3 bucket that stores the two images. Next, for the SNS service, we've created a topic where the student's email is subscribed. Next, let's talk about function calling. First, we call a recognize image event, where down here, you can see that the compare faces recognition is called. Then, the similarity log is stored as a response and returned to the main function. Back up here, the similarity is more than 90%, then the attendance taken message will be sent by SNS. Here is the test. As you can see, the just taken email has been sent.
With respect to the IoT code, we use our computer as the IoT device connected to the AWS server and allow them to send message to each other. Here is the same name, the smart class server we configured on the AWS, which represents the IoT device. In this code, we configure the certificate key and other information of the IoT scene. By subscribing to the IoT topic, the IoT device and the AWS server will connect to each other. Before we test, we should subscribe to IoT topic for sending and receiving message on the server side. Then we run the code. You send the message to the server. Then you'll see the message from the IoT device. Then we send a message to the IoT device, publish the message. Here, we successfully received the message from the server side.
For the implementation, I will be doing on the Cognito. So we will click on this student user pool, and it will direct us to this web page. Then after that, we will go for the app clients. Since we already created app clients, the name of the app clients is user students. So once we are done creating this one, then we can go for the app client setting. So for the app client setting, we have to check this Cognito user pool so that we can store users' information. Next thing is the callback URL, where we will use the localhost 3000 to return when user clicks sign in. And for the sign out, it will also return this localhost we use. And for the OAuth 2.0, we click on implicit grant so that user can be verified using either phone, email, OpenID, or profile when they are signing up for a new account in the Cognito mode. Then below here is our hoster UI, where you click this, it will send towards this sign in with your username and password web page. If you click as sign up, then we will have the username, email, and password. This email must be put the real email so that they will receive the verification ID. So since we already created an account, so I'll just show demo the ones that has been created. And click sign in, it will direct us to this smart application web page. This smart application web page, we are using the API gateway, which will retrieve data from the DynamoDB, where it will return us the students' information. So when I click on this get students, it will display the student mail testing and this dummy account. It will show us the dummy information here. Then after this, the UI here can only be created once we have our own domain name. So here, our domain name is online classroom. We can only create one domain name, and if we want to change a new domain name, we have to delete this domain and create another one. So here is the user and group. So the users, these are the two users have already signed up into the Cognito account. Then after that, in the groups, we create two groups, admin and student, so they will see view differently. So from here, the roles, this roles is created in the IAM management and is admin access. And here we we add the user, put this user in as admin. Another one, students, and here is the roles and the user. So let me head towards to the IAM management. So when we click roles, we have to go to admin access. This role is created by us. And the admin access, we select Amazon DynamoDB full access, meaning to say that this is for admin to have the authorities to read, write, and execute all informations in the DynamoDB. Another one is known as the student access. We click here, and all it can do is read the database itself. So whatever is being displayed on the screen, the students can only read. So whichever users are in the student group, they will only allowed to read. So this is all, and thank you for listening.